This is a talk on how to migrate your workloads off the mainframe. Now you are wondering, this is a Spring 1 conference, like who talks about mainframes? But the fact of the matter is we have a lot of data and apps locked in mainframes. It's tough to get to them, it's tough to modify them. They largely live in their own silos. If you have ever wondered if things could be made better, or if anything, just to challenge your sysadmin, if you want to earn brownie points on just like what ZOS lingo means, this is a good talk. Why do I feel qualified to give this talk? I spent the first 10.5 years of my career at IBM. I've worked in the WebSphere application server product, and not just WebSphere, but WebSphere on ZOS, which is a subsystem of ZOS. I have worked with DB2 on ZOS. I had some exposure to CICS on ZOS and IMS. So these are all the subsystems of ZOS. Before I get started, can I get a quick show of hands on who has worked with ZOS OS 390 before? Oh, awesome! So you guys know what I'm talking about. I want this to be interactive. This is the first time I'm giving this talk, and the topic is so broad. I've had to take a certain path through it. If you don't like what you are seeing, I will not mind if you walk out. That's fine. But before you do, at least ask me a question or two so that I feel good. Okay, what is this? This is what the newest mainframe looks like. It's Z13. This is not your father's mainframe, right? This beast processes 2.5 billion transactions a second, according to the IBM architecture. It is 2x faster than the most common server processor out there. It has 300% more memory and 100% more bandwidth. Now, why am I giving you all these statistics? Just to show that IBM continuously evolves its mainframe line. The top of the line Z13 mainframe is a very powerful machine. It is also a very expensive machine. When you pull up to IBM Global Services and make a call to buy this box, it's going to run you anywhere between $4 million to $10 million. That's the kind of money that you're looking to spend on an average Z13 box at your deployment. A lot of the enhancements that have been done in the mainframe have been around transaction processing. Specifically, this mainframe has an enhanced ability to encrypt transactions. So they have put a lot of secret sauce in security, in the JDK, in just encrypting transactions in flight. So what is this? Yeah. So this is where you want to be. This is Google's data center in North Carolina, in a city called Lenoir. Look at this thing. I mean, it's a piece of beauty. Apart from it being so beautiful to look at, why do you want to get here? Because you get on-demand delivery of IT resources. Forget that. You can actually hire Java developers to work on apps that run here. Try hiring ZOS system administrators. The second thing is it's cheaper, faster to just run applications on distributed systems. In terms of the skill sets of developers that are available out there, you can put on these distributed systems, you can put VMs, you can virtualize them, you can slice and dice them in different ways. This is an argument of distributed systems versus ZOS. If you look at the architecture that IBM puts out, they say that over the long-term life of a project, a ZOS mainframe is much more cost efficient than a distributed system. I definitely believe that is not the case. The entire premise of this talk is we want to move our workloads and data off of a ZOS mainframe to a distributed system. And when I say distributed system, this is a rack of servers here, just pure hardware. On this, you can put whatever you want. You can put virtualization of ESXi, you can put OpenStack, put Cloud Foundry, Kubernetes, it doesn't matter. The point is that you can tailor it as you see fit and you don't need specialized skills. And second thing is you will be able to meet the needs of your customers faster. So what does this give you? On-demand delivery of IT resources and applications. This is the actual definition of public cloud, that a public cloud gives you on-demand delivery of IT resources and applications. It gives you resources when you want them. It gives you the ability to scale them and so on. Modernizing the mainframe. Okay. If you were to walk out of this talk right now, this is the slide I want you to remember. What are the different approaches of modernizing the mainframe? First is lift and shift, right? You can use emulation platforms. You have emulation platforms to run COBOL, vSAM, ISAM on Linux-based environments. When you use those emulation tools and run some, not all workloads, but you can run some of your ZOS workloads on these emulation platforms, and then you can virtualize those Linux VMs on ESXi. Of the workloads that can be emulated, this is a good option. Why do you choose this option? In the short term, if you want to reduce your cost of ownership, this is a good option to use emulation platforms. And what you're doing here is in this case, basically you're looking for short-term gain, right? This is not the correct long-term solution, but you're essentially reducing your cost by moving processing off the mainframe. The second approach is the greenfield approach, and I will get into this. We'll get into this more. But the recommendation here is to completely rewrite a particular module. So pick a particular module in your ZOS application or a batch application that is relatively isolated, right? Has high strategic value, correct? So it's isolated and has high strategic value, which means that you should be able to independently write another program in Java or whatever your language choice is, and then use and completely replace it with your newer program. So greenfield approach is basically rewrite the application. It is critical that you pick the right application. And the advice is to pick a small app and first move the compute aspect of the application and then the data aspect. The third approach in modernizing of the mainframe is incremental replacement. So in incremental replacement, what you do is you pick a particular module of the bigger ZOS app and replace it with like function in the language of your choice. So to give you a good example, over here, this is a picture where the legacy big ball of mud is your ZOS app, right? You have identified a particular module that is contained within a single data domain in a single line of business. You have put a fence around it. You can leverage API modernization as a strategy to put APIs on your ZOS, on your other ZOS systems, right? And then for that particular module that you are peeling off, you write a replacement and run both the old and the newer pieces of function together till you can sunset the old function. So you are essentially strangling the existing function or the existing module, replacing it with a newer module, running both together, and then sunsetting the older module. This is called the strangler pattern. In order to achieve this, you have to create a fence around your existing ZOS. You have to create a seam or a boundary, and for that you have to expose APIs so that the newer module can talk to your older module, right? So this strategy goes hand in hand with API modernization, and we'll get into more of this later. The last approach is application tier replacement. So what this approach does is you offload certain aspects of your ZOS processing. If you pick a particular batch process, for instance, replace that particular batch process by running the same workload in a distributed environment. This is more, the app tier replacement is a bad word. It's mostly data tier replacement. The strategy here is to move the data from the mainframe to DB2 or to move the data out of the mainframe to Hadoop and then run processing outside. So this is more in terms of first pinpoint a particular workload, right? Be it, so replace the mainframe data store, which is vSAM or ISAM, and then put it in Gemfire, and then write processing on Gemfire. So move the data and then the compute. So that is application tier replacement. You would replace batch processing as part of application tier replacement. Before I move on, did you guys have questions on this slide? Because this is the overview of, these are the different strategies that I will get into the detail for. Okay, first I'll give. Yes?
Is there any limitations to the size of the workload that can be supported in emulators and the lift and shift model?
So some of the emulators are limited in terms of what they can run. And which is why for the bigger production workloads, that is not a strategy that you would go with. Your better strategy is to either go with an incremental replacement where you're essentially identifying a module and completely replacing it, or application tier replacement where you're moving the data and then writing the compute on top. These emulators only work for very small classes of workloads on z/OS. I would say that roughly 20 to 30% of the workloads can be emulated like that. So what are the mainframe integration patterns? What are the typical patterns that we used for mainframe systems and distributed systems to communicate with one another, right? So this is a hierarchy of all the software architecture patterns, implementation patterns that have been seen, which is first, all the components are tightly integrated. They call one another through RPC. This is base. And then another mode of integration is where the distributed system talks to the z/OS system via IBM MQ. IBM MQ is a great transport because all the z/OS subsystems can read from MQ and the distributed systems can talk to it through JMS. So IBM MQ was an integration tier between distributed systems and z/OS systems. The third aspect of mainframe integration was screen scraping applications. So in order to talk to a CICS application on z/OS, you use something called a 3270 green terminal. This is what is referred to as green terminals. You could put in automation to run these, to screen scrape and run these green terminals. That was, believe it or not, a way of integrating between z/OS systems and distributed systems. What has happened as at a certain point, service-oriented architecture came into vogue. At that point, most of the integration was handled by exposing web services and integrating the web services with an ESB. So here there are a lot of products like TIBCO that have mainframe adapters that allow you to pull data from CICS or IMS and then transform it and then send it over on the ESB to whatever app is running on the other endpoint. So ESB-based integration with web services was a pattern. This is the most common pattern today for integrating z/OS workloads and distributed workloads, or where the two apps have to play together in a common context. And the last one is, this is the pattern that I want you guys to leave with, which is we want to expose APIs on the existing z/OS applications, which is all your applications that are running on z/OS. IBM has made it ridiculously easy to expose a REST API and then utilize them outside. That is, and you will see the products that will allow you to do this. This is the latest pattern. If you were to modernize your mainframe app, the first thing you have to do is wrap it with an REST API. And there are tools that allow you to do this, and I'll get into that later. So how does IBM want you to modernize your z/OS mainframe workload, right? What is IBM's answer? This is something that I took straight from there, from some random slide deck. What they want you to use is a whole suite of products ranging from data power. So I will get into how you expose the APIs, but let's draw a mental picture where each z/OS subsystem, like CICS, IMS, even WebSphere on ZOS exposes, or even DB2 exposes a REST API. Those APIs need to be managed and curated. For that, you use an API management product like Data Power. So you use your Data Power, think of it like a replacement for F5. Then once these APIs, once you write applications to talk to these APIs, you have scenarios where you want to integrate with existing applications, and you want to reach out to other connectors like SAP systems or other enterprise integration systems, and that's where the integration bus comes into play. So you have your REST APIs running on ZOS, you have applications that make use of them, you have external integrations that you are calling out from the IBM integration bus that allows you to create a central point of governance. It's an ESB. And then they would like for the customers to use Worklight for their mobile solutions. And you can move workloads between your ZOS mainframe and Bluemix. So they are also suggesting that you can move your workload between, you have a hybrid cloud model where you can move data and processing between your mainframe and Bluemix, which is their public cloud. This is IBM's answer to how does a modern, what does a modern workload on a ZOS system look like? So, sorry?
How much would that cost?
This would, that's I'm having a hard time computing that answer. Like, I'm looking at these big pieces of software. So the goal here is to not educate you on what to do. This is an example of what not to do. I would not want you to go out and call IBM and get a procurement of Data Power and ESB. Right. So so of all the IBM products that they have put out, and I don't sell for, I work for Pivotal, but this is one that you should use, absolutely. This is a product that allows you to take your existing assets on ZOS, if you look at the top right, systems of record, it allows you to wrap them with APIs, which is why this is called ZOS Connect 2.0. They had 1.0, which was a complete failure, but it was the right idea. This is 2.0. So what do you do here? You use Eclipse tooling. You use plugins within Eclipse for CICS and IMS and any backend system and its application. And you develop these APIs. These are Swagger compatible 2.0 APIs. You take these APIs, right, and generate something called an AAR, an application archive. You take the application archive and run it in WebSphere Liberty Profile, right? So this ZOS Connect EEV2 that you see on the top is running within WebSphere Application Server Liberty Profile. This is the server that is exposing those REST APIs, right? And then the API archive allows you to map, to define these mappings so that when a call is made, you make the appropriate call to the backend application. So what that means is your interaction with your ZOS application is through a REST API, right? So you're no longer having to talk to it with MQ or do weird integrations like using FTP or whatever. All your interaction with existing ZOS assets is through a REST API. And these mappings, right? So this is the actual request response flow. And this request response flow, the backend system, you can replace that with IMS, CICS, and other ZOS subsystems. When you make a request response flow, you have the ability to intercept a request and do and wrap it with other transformations that you need. So a core part of defining the REST API is defining a mapping between your request and what the backend data structures look like on the respective ZOS subsystem, which is CICS or IMS. So that is what the Eclipse tooling helps, it is allowing you to do a data mapping and define a REST API, right? So when you make a call, you make a post. Say if you want to add a record or you want to update a master record on ISAM, then it's a matter of making the appropriate REST API call, which then gets translated to the appropriate call, ZOS system call.
Does that handle the apathetic translation as well?
Exactly, and that handles the apathetic translation as well. So if you see here, over here, correct, you have hooks on both on the request side and a response side to transform the requests that go into the backend system and the response that you go out. These are event interceptors that you write when you create your API export archive. So the input is these systems of record specific utilities that are put. So the input is that service archive, the output is the AAR file. What is the output? It's a Swagger compatible API definition and the actual running API on WebSphere Liberty profile. And this is so in order to build those APIs, you need to have Swagger to define the API, and then you need to have utilities to map the requests to actual backend data structures. For that, there are plugins in Eclipse for each ZOS subsystem, like IMS Explorer, CICS Explorer, and so on. So you need Eclipse, you define the API, you run the API, and then all your integration essentially becomes making REST API calls. Okay, SOA and legacy integration. I'm getting close on time. If these are other modes of integration that we have seen. In the first one, where we simply use lightweight integration frameworks like Spring Integration and Spring Batch. The second model of integration is to use the ESB, and this is a repeat of the previous slide. And the third integration is using the third aspect is not only using ESB but also using other integration suites. So if you have a current SOA portfolio of web services, right, you are integrating these services using either Spring or Camel. The second, these are lightweight integration frameworks. If you have an enterprise service bus, you're probably using that to couple your service consumers and producers. And the third aspect is you may also have a business process modeling engine along with the ESB. So these are three different aspects of SOA and legacy integration. Save money. This is important. If you have a current ZOS workload, how do you save money? This may not be pertinent here, but for public service, I felt like I should include this slide. One of the key things with saving money is you have to move from, if you're using ISVs on your mainframe, then see if you can move the ISV workloads to using COBOL and DB2 provided by ZOS. Leverage the latest features from the ZOS transaction managers. The ZOS transaction managers are IMS and CICS and WebSphere ZOS. Compilers matter. So if you are using COBOL version 4, you may want to go to COBOL version 6.2. Just doing that gives you 30% improvement in throughput in some cases. IBM has also introduced tools like application binary optimizer, which automatically looks at your older COBOL code and figures out optimizations and then improves the throughput. If you're running Java programs on ZOS, use the latest and greatest JDK because they put all the functional enhancements and performance features there. Offload all in ZOS. You can offload your processing of databases. You can offload your DB2 workload and your Java workload to specialized processors, which is what this is, offload processing to zip and zap processors. And the last thing is, if possible, externalize your business rules outside of ZOS. Don't run a rules engine within ZOS. Use something like a process server or a rules engine running on a distributed system outside. So the idea here is to reduce the amount of business logic on ZOS and instead centralize it outside. Batch modernization. This is a big, the biggest part of the workload on ZOS is batch. How do you modernize batch is a few things. One is make sure that the current batch processing, you're addressing the gap where your batch process runs together concurrently with online processing. I'm going to hit just the key ones over here. Don't use batch for app integration. If app 1 wants to talk to app 2, don't use batch for integrating that. I have seen patterns where app 1 writes a file and then app 2 will read the file. You don't want to use batch for integration. Use maybe message queues or just do real-time synchronous API calls or near real-time asynchronous calls for batch instead of using batch for integrating everything. Spring Batch on PCF, move your batch workloads to distributed systems using Spring Batch. Spring Batch today runs on PCF. It can run even better when the Diego task API shows up. But we expect that in the near future, Spring Batch will be able to scale dynamically, run as a first-class citizen within PCF. The basic problem today is Pivotal Cloud Foundry expects applications to stay around forever, whereas in batch, we all know that once the batch process is done, it exits. There are constructs within Cloud Foundry that allow you to run one-time tasks, and in the future, this support will become full-featured. And at that point, running Spring Batch on PCF will be very natural. One of the key things with respect to ZOS modernization is data, right? There are two things that keep applications on ZOS. One is transactions. You have COBOL and all the data that's locked in the database. This data primarily resides in either DB2 or it's in ISAM files. The recommendation here is to use ETL to load the DB2 data onto an in-memory database. A good candidate is Apache Geode. There are so many features here that I had to describe it in 2 slides. The idea here is whatever transaction processing that you are doing on ZOS can be done in Apache Geode. And in fact, you can do it in a much more performant fashion, in a cheaper way, just due to the nature of how Geode is architected. It is a highly scalable in-memory data grid. It allows you to do WAN replication. It allows you to define continuous queries. It has binders that bind it to Spring. So you do not even have to write Apache Geode code. You have to write Spring data. You write code in Spring Cloud Data Flow. So you are writing data microservices that are running on top of Spring Cloud Data Flow, which bind to Apache Geode. I know this is a lot to absorb, but what I'm trying to convey is move your data to Apache Geode and then either process it on Geode, either directly using Apache Geode APIs or use the Spring Cloud Data Flow abstraction, so that in the future you could, instead of binding to Apache Geode, you could bind to Hazelcast for that matter, or whichever distributed grid you like. This is a slide where eventually, once you start writing data microservices in Spring Cloud Data Flow, they can run on any deployment environment. For instance, they can run in Cloud Foundry, on Hadoop, or whichever. The last part, because I have only 1 minute left, is you can also offload data to Hadoop. There are a number of tools from Informatica, from SyncSort, using just Apache open source, where you can take data, where you can offload data into Hadoop, and also if there is a use case, also take data from Hadoop and reload it back into the mainframe. So if you want a target to move data, you have either an in-memory distributed data grid like Geode, or you move to a Hadoop distribution. That was the last slide. So it's 5 o'clock. I know this is it's a broad topic. I had to take one slice through it. You guys have questions?
Just real quick, how urgent is it to start making these moves now? Because I noticed a lot of my friends that have been doing COBOL This really seems like something very important, for a lot of enterprises.
Yeah, I mean, there are two aspects to it. One is IBM is making it at least easier by providing tools like ZOS Connect to bring a lot of the ZOS systems into the modern world. This is a way to, and so the hope is that the newer developers don't really have to interact with, they don't have to know the ZOS commands to start up WebSphere, for instance. There is no good answer. It needs to be done immediately, or you have to establish an in-house program where you pair your senior ZOS guys with your junior ZOS guys, and you have to incentivize them to stay. It's not that we can't bind them to servitude, so you have to motivate them to stay and learn and want to do this. This is one of the reasons why we have this talk here, because even though the mainframe may be the best piece of technology ever, there are the people who understand and run this are disappearing.
Yeah, I think they did some survey about ZOS system administrator average age. It was 56 or 57 years.
Right.
A lot of them are retiring and then they're not able to track them down.
Any other questions? Oh, okay, we're done. Okay, sorry. Thanks, guys.